Hello. Welcome to another stream. And today we're going to keep working on Pathos, our library for Swift. And the purpose of the library is file systems. You have stuff on the file system, you want to change them, look at them. This library lets you do that across different platforms with the same set of API. And before I do that, just forgive me, I'll hide my screen for a second. All right, much better. Okay. So I am in the middle of implementing Real for Windows. And I just realized that means I probably need to use the Windows machine a bunch. Which means you might see some of these setups. I'm trying to see if I can improve it. For some reason, this speech bubble is not working when I hide the window, which is a browser window, which was not the case last time as far as I can tell. Maybe I was wrong. Maybe I was misremembering. Okay. And also when it makes some mistakes, it's kind of hilarious. Anyways. Okay, I think it's working. I just need to not minimize it. Yeah. Apparently that's important on Windows. Okay. All right, so let's do this. I have implemented Real for Mac OS and Linux, as far as I can tell. Let's run some tests on Linux. I'm going to launch Docker. Hello? Docker spelled as a 2005 web startup without the E. Okay. So I'm launching the Docker daemon. While I do that, let me just explain. The Real is supposed to give you the actual path of a given path. So why would the given path be quote unquote fake, right? So that is mainly due to symlink. Assuming the path already exists, really actually somewhere points to something on your virtual file system. That thing might be a symlink. A symlink, points somewhere else, right? It's a pointer. And furthermore, the path from root that leads to that path might also contain some kind of symlink, right? Let's say folder A contains folder B, contains file C. B could itself be a symlink to a folder D. So the real path of C in this case could be an entirely different path from A and then go to E and go to F or whatever, because there are several layers of symlinks in 2 dimensions. One is, yes, the folders, your parent folders, one of them could be a symlink. The symlink itself, any symlink, could also point to other symlinks, right? So symlink to the real thing, or any arbitrary level of indirection like that. The real path resolves all these symlinks and actually give you the final path that doesn't contain any symlink given your path. So like if you give it A/B, A being a symlink, B being a symlink, it will resolve both in A and B to the point where they're no longer symlink, or they found a loop. In that case, it just give up and give the best it can find. Yes, but caveat here is like, eventually it will return a absolute path from your drive or route or whatever. But the absolute path, I mean that would work with the current working directory if it's relative, your input is relative. So I think anyways, the final result won't contain any symlink. That's the point. And I've implemented I've tested it on Mac OS. So let's run the test on Docker. I have no reason to believe it doesn't work on Linux, but we'll see. And I guess while we're here, let's just look at the test real quick. Whoa, real test. Okay, so there are 3 simple tests. This is also a opportunity to showcase what we have for this iteration of Pathos already. Looks like our test passed. Okay, so let's look at what we just ran, right? So we construct a temporary directory that takes a closure, and inside the closure, the current working directory is set to a temporary working directory. After this closure, the current working directory will get reset to the original current working directory, and the temporary folder along with its content gets deleted. Okay, so this first test is very simple. We create a path, call it origin. We create a link, call it link, right? At this point, these are just path strings in binary form in memory, and we make a symlink from origin to link, right? So now B is a symlink and it points to A on the file system. A still doesn't exist, but that's okay. Symlink can be quote unquote broken. It just points somewhere. It doesn't matter whether that somewhere is actual or fictional. All right. And then we call link.real. Link.real, as I explained earlier, we'll try to find all the symlink in the content of link, which is B, and find the actual result of it. And that will, as you expect, become A. So we assert 2 things. 1, the result is absolute. Second, the result has the final component being A. We have to check the final component with .name, because here A will be turned into a absolute path. So start from, in this case, root on Mac and Linux, and then all the way points to the temporary directory that we just created. So technically we could take the temporary directory and assert that the whole path is the temporary directory, but that's like testing extra things. So I just want to test the part that matters. So we just assert the name, which is the last component of the path. The absolute path is what we expect. Okay, that's the first test. So second test, third test has a similar setup. We also still works within the temporary directory, but for the second test, we're having 2 levels of symlink. So link 1 points to origin, and link 2 points to link 1, right? Origin make link at link 1, link 1 make link at link 2. Now we're asking for the real path of link 2, which is C, it points to B, which points to A. And our result should be the same as the first test, which means the result is absolute path and its final component is A, right? C points to B, points to A. Okay. Third one. This one, we're making a directory, name it dir, Okay, and then we'll make a symlink to it, dir link, right? Dir make symlink at dir link, and then we will make a file path that this is actually what we expect to be in the file path, which is dir link plus a. Sorry, not what we expect. This is a fictional file within the directory that is symlink, right? So this will be dir link /a. And then we're asking pathos, hey, what is the real path of a? Given that it's dir link /a. That's long-winded way for us humans. It's pretty easy to infer that the result should be the real path of dir link /a should be dir /a, since dir link is a symlink to dir. So that is absolutely what we're asserting. We're taking all the segments and then make sure that the last two components are dir and a. The way it's written this way instead of dir /a is because this test will work is designated for all platforms. On Windows, that would be dir \a. So we don't want to write two set of tests for the same thing. So it is. Okay, so that's real. And as you just saw, we ran the test for Linux. It works. Now we're going to, well, obviously this green check mark indicates it's working on macOS, right? This is Xcode. Now we're going to switch to Windows. And I know Windows doesn't work because I have a pull request here that failed. Yes. So not only it worked on Linux, it worked on all the distros that Swift officially support. So the only thing that left is Windows. I'm really tempted. If the CI is really fast, I would just work on this machine, but unfortunately it's not. So we'll have to switch to Windows machine and run this build and run with CMake. Okay. Hey, Nita. I do use Vim to develop Swift most of the time. It could be worse. It's a lot better now that we have LSP. And the reason I use it is mainly habit. Like I've used Vim since I was 12. So it's just, for me, it just feels, it's a muscle memory. Okay, so there are 3 failures, unsurprisingly, because this is a branch that implements real, and we just described 3 tests. So none of these passed. I'm not surprised because I don't even know what is actual Windows. What is the actual implementation for Windows? So we have a real path. We'll use this in the actual implementation. Okay. So right now we just call this this private real path thing. And real path, I remember, is just a call to a Windows call named get final path name by handle W. Okay. So let's just Google that. Go to its documentation rather. Okay. So the documentation states this function gets the final path for the specific file. If I remember correctly, there's actually a function that Windows provides that does the real path stuff. So I think before I dive into like copying CPython's implementation, let's say, I want to actually recover that piece of information somehow. I vaguely remember it's in shell something. Is it in here? There's a thing called shell w something. Okay, so I guess the way to find it is Swift ships with code Swift. Yes, yeah, perfect. So I made a change recently to it. Along with it, I was looking at this header file, and it has some interesting stuff in it. I remember taking a mental note to go back here. But maybe it's not. Oh, I also remember have another mental note that says discarding the previous mental note. Let's see. So this is a set of functions that's used to implement a terminal, if I remember correctly. So it's very interesting, right? It's like it has some C++ APIs for reading and setting and writing files. So if I can call into those, it will actually help me a lot, right? Like parsing a URL, adding a backslash, adding an extension. Like it's very canonicalize. Yes, let's take a look at this. Okay, so this is just normalizing. But if I remember correctly, it doesn't deal with symlink. Yeah, so it just removes dots and double dots, which already do with our existing facilities. Yeah, so there's some examples, right? The dots is redundant in a path, and double dots indicates you should just go back 2 levels. So C1, 2, 3 will just become 1 and 3 because this one skips 2. Yeah, something like that. We used to have that. We may still add it, but for now, it's not our goal. A's directory. It's very interesting. We've actually implemented a lot of these in other methods. I guess using lower level APIs. Path is prefix. Path is relative. Okay. Path is root. Path is system folder. Path is UNC. Path make pretty. Converts all uppercase path to all lowercase characters. Give the path consistent appearance. See, this is very high level, very user-facing APIs. I mean, end user. Let me just search for the word symlink. Okay, symlink doesn't even appear here. Should I give up? Because like I should rely on my visit history, right? Like if a link is blue, that means I never looked at it. That means it's not related to my mental note. I really should have taken real notes, but I assume it's just some lazy browsing when I did it. Make system folder is URL. Okay. Okay, maybe canonicalize is what I remember, and of course is not what we need to do today. All right. Unfortunately, we have to go hard and do it like this. So I've done some research last night and looked at how Python implemented all this stuff. And this is the actual implementation in CPython today. So I'm just going to shamelessly, read the code and rewrite the same logic in Swift. Since, and I assume it will do the right thing. We'll find out at the end, right? So there's this, in Python standard library, there's os.realpath. And this is the implementation for NT kernel, which is, Windows. And in Python, they always deal with this binary versus Unicode thing. So they always has two copies of what is the prefix, some constant, set up some constances, and normalize the path and all that, and a case for the path and all that. We don't have to think about that because we use binary exclusively. So this function essentially it will call this get final path name thing, and then it's like if it's find any error, it will call this other thing, right? So this is the core logic here, these two. And then after they're done calling those, they'll have to deal with this backslash question mark backslash thing. So if it starts with backslash backslash question mark backslash UNC backslash, they will replace it with new UNC. So just backslash backslash, right? Just remove the. I don't get it, but okay. Well, we'll do the same thing. Otherwise, we just delete the backslash. Okay. I mean, this is optional. Yeah, this is a part on Windows that I haven't thought of because it's not really a cross-platform problem. But in practice, it's probably, pretty important in terms of users' expectation of what constitutes a path. On Windows, latest version of Windows, they added this special prefix to inform the operating system that this path can go beyond the traditional character limit for the length of a path. But I think most users probably don't really care about this. So it may be weird if, say, you are building an application, you use pathos, and somehow it spits out this kind of path to users. But, it's arguable. I have no idea what your Windows user expects these days, especially for the people that actually understand what the path even is, right? Maybe they all have the knowledge now. Anyways, this is an area of things I need to research further. But let's just take a look at get final path name, which is what I believe. Another note is get final path name is just what we have for real path right now. So you have to trust me on this because I don't want to exit out this file at this moment. So which brings us here. We have NT read link. Sorry. So there's get final path name non-restrict, which is let's call the getFinalPathName method. If it gives one of these errors, then we will call readLinkDeep and return the result, essentially. And readLinkDeep is implemented right here, which is we read link, and then if one of these results are returned, then we do some more stuff. Okay, let's do this. I'm gonna write the code here and switch to Windows when it's time for compilation. It's gonna be a little rough, but we'll get through it. Path plus POSIX, right? Windows. All right. Okay. So does this get called recursively? No. Okay. So how does this work actually? So there's a scene, so it's some kind of cache, and then we're like, if the path is not in scene, we add it in scene. And then we'll do a set of operations. Okay. We create a copy of the path and we read a link of the path, assign it to the original variable. And then if the path is not absolute, we'll look at whether the original path before it's read link is a symlink. And there's a note here, if it's other than symlink, we don't know what it is actually going to be resolved against, so just return the old path. So path becomes old path, break the loop, return the path. Okay. So if in this exercise we encounter one of these errors, we break and return. Otherwise, we really throw an error. Okay. So this is the core logic here. We just say if it's the symlink, we'll resolve the symlink, right? Okay. But if it's one of these errors while reading the symlink, that's okay. We'll return the original path. So when we call this here, it's similar in that we call the getFinal component, getFinalPathName from Windows NT. And if throws one of these errors, presumably because the path is a symlink or something, then we'll call the thing we just defined. And if the read link functionality returns the new path that is different from the old path, this is in a while loop. Okay. So this has some kind of effect. So let's read this. Take a deep breath and take it all in. You start with the empty tail, right? And assume this will slowly accumulate the entire path. So let's look at what happens to tail. Tail is name joined with tail, if tail, else name. It's crazy that I've implemented enough. I've played with Windows API enough to understand this comment. So maybe we can actually implement this to-do that's left in Python for how long now? Oh, since last year. Okay. So this function used to be somewhat simpler. Until the Steve guy made it a little bit more complex. Okay. Hey, you know what? Maybe we can turn this stream into contributing to Python and actually... it's a thought. It's a thought. Because I can finish that to do. Okay, let's go. Let's implement this. So we have a read link, right? And it throws errors and it returns a path. Okay. Have this list of errors. So let's just shamelessly copy, turn these into Swift comments and allowed error. Okay. So we'll have a set of paths, mutable, set. Okay, sorry about that. Got distracted by something here. All right. So we're gonna go into a loop, and then in the loop we'll repeatedly say, okay, is the path as is the input? Okay, so we'll have to give this guy an input, I guess. So, and we'll have to make it mutable. So I'll just make a copy here. If the path is not in our set yet, let's just, you know what? Instead of trying to understand everything up front, I'll write it. After writing it, usually it helps with actually understanding the whole picture. So while the scene does not contains, doesn't help that this is in a conditional block that's false in Xcode right now. That's a pickle. What to do? Oh well. If the path as of right now is not in scene, we shall first add it to scene, right? Scene dot, I think it's insert. Set insert. Yep. We put it in our thingy. And then we will make another copy, old path. We will try to read the link. So we already have read symlink, which is working on Windows. I spent quite a bit of efforts making it work. I think it's on stream in the past. So if you're interested to see me struggle, feel free to go back to the VOD. So if wait. So this one overrides the link variable. If path is absolute, path equals old path. Okay. So there's some kind of preference to absolute paths here. Okay. Finally, path is old paths directory. Wait. Do I have? Wait. Path.swift. Do I have a thing called directory? Yeah, parent, right? It's called parent. Come on. Yeah. Okay, so we join old path's parent with the path itself. And then we'll have to catch the error thrown from here. That's inside the loop. So error could be thrown by this try, and we'll do the logic in a do block catch. Let's see. Error has a raw number, right? This is awkward. So the error as of right now is kind of a pain to deal with. Okay, so I'm gonna add enhancer error by giving it a raw value thingy. Raw value returns the code, and we're gonna switch on ourselves. And this probably needs 2 separate implementations as well, so that's okay. If OS is Windows, we'll do one thing, else, assume it's POSIX. Really, it should be else if, and then a couple of asserts, but that's a very long assert. So we'll just do else. And then we'll switch on self case file exists, return this guy, and we'll have to turn it into a code. Case unspecified. Okay. Well, this will expand before we actually release the library, but for now, the file exists is the only thing that I need internally for the implementation of the library. File exists, return e exit. E exists. Otherwise, okay. Wait, can I do this? Set equals this literal. Let, of course. Nice. Okay, so we called the error. Error has a raw value. Now we can compare the raw values. This will be system error.code. Okay. So if error dot oh no, this is, we have to do like let error as system error. Catch throw error. Okay. So if error dot raw value is one of these, right? So loud error. Then we simply break. Otherwise, we throw. Okay. I feel like this can be written here with a where clause, but we'll see. This appears to be everything this function does. Except we, of course, need to return the value of path here outside after the loop. Okay. So we get some basic syntactical checks from the compiler, which is better than nothing. Okay, so this is a nested function, so it's only available in this scope, right? Now let's write the next part, which is this non-strict thing. So what should I name it? I don't know. Get path name. It takes the path, throws error, returns the path. Okay. Then we'll do the same thing. Copy this different set of error codes. This is allowed errors set of system error dot code. Okay. And then we'll do this tail eating body exercise, right? I think after writing this, I have a pretty good understanding of what's happening here. Right? So things start to jump out of the loop if we throw an error. So, but if we're not throwing errors, that means our path gets converted to a new path. If it's an absolute path, wait, is this inverted? If not absolute. If after reading the symlink, the path is not absolute, we undo the read, and then we just return it. Oh, no. I think I did something wrong, right? If it's not symlink, if it's not absolute, oh, I missed something here. That's why it felt a little bit nonsensical here. Okay, good. If old path, I guess we'll have to try old path metadata file type is symlink. So if it's not symlink, meaning this whole expression is not true, could be nil. So we have to write it this way. Then path revert back to old path. Break. Okay, so let's try to read it again, right? So we read a symlink of path. And I think this needs to go in here. Okay. So if path is absolute, we continue the loop. So if path is absolute, let's just ignore this case. That means we read the symlink for the path, and then we put it into our little set here, and then we read symlink of that path. Okay, so if the path end up being another symlink, then we just repeat until it's no longer symlink. And how that works is the thing will remember all the actual results from read symlink. And if the results start to repeat, that means we've encountered a point where there's no longer a symlink, right? You read a symlink, and then you go back and read the result of that. It turns out it's the same thing. That means it's not a symlink. It's just the path itself. That's where we can stop the loop by this condition. Now, if the link is not absolute, then we go back and ask, is this path even a symlink at all? Even though we're already attempted to read the symlink. If it's not absolute, it's not a symlink, then we're done. Right? Path equals old path, break out the loop, return the path. Okay, that's actually somewhat comprehensible. Yeah, we'll just keep reading the link until it's no longer a link. Otherwise, yeah. I don't know. Yeah, it's just some kind of yeah. So, real tests. So going back to our tests, right? I think, if we just use that function, it will pass these two. Obviously, we'll dress it up a little bit more. These two tests. I'm not sure about this one though. Maybe that's what's the next function does. So let's just resume writing code instead of reading code. All right. Okay, so we already created this list or set of allowed error code, and we're gonna create a tail. And then while the path still exists, let's do that first, make the mutable version of the path. Side note, like this seems a little bit inefficient if you're really sensitive to performance, but we're hitting the disk repeatedly here. So the performance of our own code in memory is irrelevant at this level. Like we'll just look at some few bytes of strings and move them around, allocate memory for them. It's order of magnitude faster than when we actually go out and read the symlink. So it's not a huge deal here. Okay, so we start off with an empty tail while path still has content. So these two conditions together already tells me we're going to slowly take parts of the path and add it to the tail. So we're going to try to call get final path name by handle at the path. And if it succeeds, we join the path and tail. Okay, so this part it's already starting to make sense. I realized like these things are easier if you to read if you just read the happy path, right? The happy path here is we're gonna take the majority of the path and convert it into the real path. Call the system call get final path name by handle. And what this does is if the last component of the path is a symlink, it will turn it into the real link, real location. So we do that, and then we take the tail and rejoin them together, return. If that's not the case, then presumably somewhere down here, we will chop off part of the path, put it into the tail, and then call the same function again to the newly shortened part. Presumably there's a symlink in there. I assume that's something like that. And this also indicates that if there's a symlink somewhere along the way from path to the last component in your, from root to the last component of your path, Windows API will throw one of these errors, and then we will loop back and fix it, and then try again. Something like that. Okay. I think reading the code slowly like this actually saves us time because I anticipate we'll have to debug somewhat. So it's really important that you understand the code before you attempt at debugging it. Sorry about that. I just opened a thingy and it's not what I thought. Okay. I just realized why does the description of my event says this? I don't know. Okay, sorry about that. Just got distracted real easily. Okay. Okay, wow, we still have the same line of code, huh? Okay, let's write one more line. Let's figure out what happens to the tail, right? The tail is gonna be, okay, it's updated when we encounters an error, right? Yeah, let's just make a real path for the tail. I did the same thing earlier it's really awkward to make an empty path, but I don't think it's worth making some reusable code at this point. So let's just make an empty path. To do that, you do something like this, and then you make a pure Windows path, and then pure Windows path takes something like parts, and then you do path.parts, and path.parts takes some parameters like nil, like root nil, and segments. It's going to be an empty array. Right. So we have to call it tail. All right. And then while path is empty not, we'll do our deeds. So path, I guess, do catch wow, the text to speech thought I said to hatch. Is it my accent? Has to be, right? All right. You know what? I'm gonna pour more coffee. I'll be right back. All right. I'm thinking. Maybe this guy should get a rename, right? Let's call this. Oh, you know what? I'll keep it as is while you reevaluate the names as we go. Okay, so path is gonna get updated by calling that other method. Okay, and assuming everything works, we're gonna say, oh, wait. All right, we're reading here. I was confused by the highlight. Okay, and if it works, we sort of say return tell dot is empty. If it's empty, we return the path. Otherwise, we return path joined by tail. Okay. And then we deal with the errors. Let me just sip the coffee real quick. It's really full. I made more than usual today. Sorry about the sounds. I personally really dislike chewing sounds, drinking sounds, swallowing, smacking, especially when it's recorded up close from a microphone. It's a pet peeve of mine. Like, no matter how much I was enjoying a stream, as long as that start to happen, I turn off the stream. So I'm going to try very conscientious to not do that. And I think I have to get some kind of widget to mute myself quickly. Because right now I have to go here, open a window, fumble through the control and click a thing. Because it's on a different machine. So you can still hear me, right? Okay. For some reason, the captions stopped working. But now it works again. Okay. All right, let's see what happens when we see an error. Yes, so of course we'll do the double catch. Let error as system error. And in general, we just rethrow the error. If this is a system error, if allowed errors, oh, I need to fix that. Error.raw value, else throw error. Okay. I just realized this variable name is terrible, so let's fix that. All right. So if we found one of these allowed errors, then game on. Let's write more code, right? We're going to we're going to say new path is calling the thing we just wrote, read link path. If new path is not the same as path, oh, this throws, so we need to try here. Wait, what? This comment is so nuts here. Because it says if it's an OS error, just ignore it. Ah, OS error. Accept OS error as X. I don't get it. What's the point of throwing error here at all if we're just going to ignore it later? Right? Especially here. So effectively, this might as well not throw any error. Okay, well, follow along, but it's strange. Okay. So this is more like if let this, right? Oops. Then we're going here. If the read link actually returns a different thing, then new pass join. Oh, this is again. Wait, am I reading the right thing? Yes. Then we do till is empty. New path. Otherwise, new path join till. So same thing here. It's interesting because we're using error codes to indicate yeah, using errors as a control flow. If certain error code shows up, we'll do more legitimate anticipated operations. Otherwise, if this thing if it fails, we just swallows the error. Okay. But wait, there's more, right? In this loop, when the error happens, we will split the path into a path and a name. So that means path will become path's parent, and name will be, well, name will be path's name, and path will become path's parent. So if path is empty not and name is empty, which will never happen in my implementation, but we'll follow along. We just join path plus tail. Wait, does this just swallow the name? Okay. Anyways. Then we update the tail to be name plus tail. If tail, otherwise is name. Okay. So tail is empty. It's just the path created from name. Otherwise, it's name plus tail. Okay. No idea whether it works. Such is the nature of writing an API for one platform on a different platform. But we'll keep going because we're at the last stretch now. We've written two internal functions, one calls the other, using various error handling as control flows because Windows. Now it's time to write the real thing. So these Python code, they deal with the path as a string. So they have all these assumptions about stuff. But it doesn't matter to me because I can update my logic to match. So for example, right, has prefix here starts with deals with the path directly, but for me, these prefixes will end up in the root or the drive or both. Okay. All right. Probably both. Okay. So had prefix will be self dot, I guess just directly root has wait, how do you do that in Swift? It's starts with? Yeah, it starts with. Okay. Starts with prefix is question backslash question mark backslash. Okay. So either this or drive. I guess we'll have to define prefix here. So if does not have prefix and not is absolute, so we turn it absolute if it's not absolute already. Wait, path. Path is, I guess in this case would be self, right? Okay. Then for some reason they're keeping around this initial win error. Let's see where it goes. Oh my god, okay. Yeah, I gotta admit, it's kind of emotionally difficult to deal with complexities when it's for a platform that you don't use. Hey, Gilad. Okay. Is it copying Python time XD? Yes, it is. Big time. And is one of the more complex cases. So where I am right now with the project is I'm almost done with everything except this guy, which is required to fix this, and then this guy. And then the expand user thing, which Gilad is very familiar with. But those are relatively simple when compared to implementing the real path and then the glob. Glob, I think, is going to be easier because I kind of have an idea of how to implement a region from like just first principle point of view. A real path is just dealing with Windows API quirks. So I know what you mean. Had a task to fix WatchOS stuff and couldn't bring myself to care. Yeah. Okay. Yeah, after I finish the list, I'll have to write, I imagine, a bunch more tests because the tests are built on top of each other. Like, in order to write some tests for a set of APIs, you have to have already another set of APIs, right? Like, if you want to verify that read works, you have to have write. And you have to verify write works. You have to have read, so they verify each other. So in that sense, a bunch of stuff I imagine haven't verified has not been tested yet. So lots of tests, make sure things really work on all platforms, and then there's some Windows specific details like what is the max length for Windows, and this prefix stuff I'm dealing with right now. All needs to be figured out. And then probably like a 1.0 alpha or something. Ooh, home stretch, exactly. By the way, I set up this speech bubble thing, and it's really awkward because I have to keep the browser window in the foreground in order for it to actually update. Okay. All right. looks like our next step is try to call the other thingy. Oh, sorry, that's not how you do it. You do this, and then you say, hey, path, give me your real path, right? Really need to rename this. Super misleading. Okay. Catch the error. Catch the rest of the error. Throw them away. I mean, not away, but throw them up. Wait, do I need to do... Maybe I can do this and just chill, right? The initial error is error here. And then we call the other thing. Well, get final path name this guy, right? Call this guy. And that guy may or may not throw again, but that's okay. Okay, now we have a path value that we like. The path returned by get final path always starts with this. This is true, actually. Wait, is it true? Because we're using get final path name by handle. Yeah, it's probably true. Yikes. Okay. Is source is broken because there's if Windows somewhere. Yes, this whole file is enclosed with the compiler condition for Windows. Yeah, just like a tangent on a tangent. The reason I try to originally I envisioned after this is like implemented and tested, I can, pitch the library as a official Swift library on Swift.org. But recently there's open sourced a system library that, you pinned me on Twitter about it. But like sounds like they have their own plans to make Swift PM and SourceGate work on Windows. The way they do that is to, wrap a bunch of system APIs and then make them work multi-platform, not cross-platform. I think that's kind of dubious because, like, are you really ramping all the low-level APIs and leave it up for the different projects we implement the higher level ones, like traversing a directory or something? Or are you actually going to wrap more and more stuff and build maybe arbitrarily more complex higher level APIs on top of system? Unclear. But yeah, they seem to have plans to cohesively move all these projects forward on Windows. It's whatever. Yeah. I forgot where I was going with this. But, I think it's still immensely valuable to have a cross-platform API that works on a higher level. Like if you want to just write some applications, either GUI or text-based, you don't really want to like do a bunch of if OSs in your code base. So that's where you use Pathos instead of system. Anyways. So if we don't have a prefix and path starts with, so this is again is the awkward part is we have to do drive starts with prefix or root starts with prefix. Yes, I've yet to read through the system API or design doc. I think much better preferring simply unified API. Yeah, that's how I feel as well. I think it's valuable to have both. Like, they just are totally different libraries. I can see this library implemented on top of system when it's, actually support Windows and has enough APIs. Yeah. Yeah, the system library is, as advertised, it's system APIs wrapped so that it's easier to use with Swift. Pathos, on the other hand, the story is you have a file system, you want to look at it, manipulate it, and this is what this library does. So it's related but orthogonal. Anyways, overlaps but also different purposes. So now we have to deal with a UNC prefix. Let UNC prefix be that. Okay. Man, this repetitiveness makes me want to write a helper function. Right? This guy, it's a string. Takes a string and returns a bool. And it's like prefix. So drive starts with prefix or root starts. I don't know if this is worth it with prefix. We'll see. So drive starts with prefix or root starts with prefix, then the whole thing starts with prefix. Coming back here, now this can get simplified by saying just self starts with prefix. Here again, it's similar story. Okay. Wait, what's S-path? Did S-path exist before this point? No. So S-path is a new UNC prefix, which is the 2 backslashes. Okay. This is awkward. All right. Another helper function, I guess. Private. Oh, this should be a function, right? Drop prefix. Dropping prefix, right? Dropping prefix. Okay. If let drive be drive starts with prefix string drive oh man, let's do a playground. Okay. I'm too lazy to remember or look up documentation, so I'm just going to play with this instead. Because I want to drop 2, right? But this won't work because that's not the right index type. So it would be index start index. And then index start index offset by 2. Wait, isn't that just like postfix or something? Prefix? Suffix? From s dot index start index offset by 2. Right. So it has to be like that. Is there an even shorter way to do this? Guess once I have that, I can use this syntax as well. Right? Okay. Awkward. All right. Or can I do suffix this and then okay, I can do this. That's faster. So convert that to okay. Drive.count minus prefix.count. Okay, so that's drive, and very similarly, we'll do this for root. Root. Root has prefix, then we use root. Wait, what I'm doing here? It's should call like a suffix, right? Suffix, yeah. Suffix. Then can delete this now because suffix takes an integer. Similar here. Suffix. Right, and then turn that whole thing into a string. Okay, then we piece together a new path, which is a pure Windows path, which takes some parts. Which has a drive, root, segments, Oh, right. New drive. Okay. All right. Now, where was I? Okay, so I'm going to start using that right away, right? If we have a UNC prefix, then this is where we start to make a thing called an S path, apparently. So S path, I assume is like short path or shortened path or something. It's a path and it's from one of these two branches. So it's guaranteed to be initialized. Man, this is so awkward. Because not only I need to drop prefixes, now I need to add prefixes. Okay, I'll be right back. All right, I think for this one, I'll just bite the bullet and add it manually here. So we found a UNC prefix. We're going to drop it. Yeah, this is where assuming a path is immutable makes it kind of inconvenient, but I'm the implementer, so I can deal. Let me deal with this. Yikes. So instead of calling starts with, I can call has prefix, right? This is presumably more optimized for string. Maybe. Okay. If man, this is awkward. Okay. If path dot root has prefix UNC prefix, then S path will be path pure Windows path parts neat let's start with drive. The drive for this will be the original drive minus the prefix, but with a new prefix. Okay. New drive will be the new UNC prefix is just 2 backslashes. Okay. So new UNC prefix plus drive suffix drive.count minus unc prefix.count. Okay, so that's the new drive. And then root remains the same. Segments remains the same. Okay, so that's S-pathing this branch. The next branch is extremely similar. If this, except this is now root. New root is new unc prefix plus pass.root suffix pass.root count minus unc prefix, something like this, right? And then as path will be drive root is okay, and then the next branch simply is path is path dropping prefix. So this whole thing just got called once. Ugh, that's gross. Okay. All right, this is so nasty. But I think I won't change the design for path parts unless I encounter another case like this. Yeah. Okay. So we have this S path thing, which drops the various prefixes. And then what we're doing here is we call sPath.realPath. And then we're like, if this is the same as path will become real sPath. Catch if the error, catch Okay. All right, so having done all that, we are done. Oh boy, that's a lot of code. Yeah, and the funny thing is, I have no idea whether the code even compiles because we're compiling Windows code on a macOS machine. So now it is the moment of truth. I'm thinking. Maybe we'll try to stay on this machine, right? Let's try stay on this machine. I'm just gonna sync the code between the two machines with Git. And let's see how far that gets us. So these are the code. I don't know what it is, but let's call it... Actually, what is the last commit? Implement for Windows. Good enough for me. Let's just amend that one. Push this up. I'm gonna open another window here. Log into the Windows machine. Source. I think it's in here. Okay. Oh no, it is not. What is it? Oh yeah. Tilde is not a thing on Windows. Okay. Sorry. Great. It merged something. There we go. Enter the build environment. Probably need to delete some temporary files. There we go. Here comes the syntax error that we don't see from the wrong platform. Okay. All right, so 318. Some of these errors is going to be dumb, but like this one, for example. Okay, read link. I guess I'll just do something like this. Cannot assign to property name. Name is a... Okay, 374. So this is a declaration, I guess. Let's see. Name gets read a few times, but never... Okay. Ah, right. The name property itself. 377. Right. This is fixed after this. Same thing here. Error expression is ambiguous because path name plus tail. I think this after this it's no longer ambiguous. Oh. Get final path name. And on line 42, yeah, what is the actual value here? This is after we have caught the initial error, right? Caught the initial error. Path. Okay. Okay, path as prefix. Yes, drive is an optional, so 409. More stuff here. I guess we have to unwrap drive equals drive suffix, drive count, unc count, new drive. Okay, same thing here. If let root equals pass.root, root has prefix. Okay. Path drive, new root, segments. Okay. $409. Okay, I think I've fixed some of these up. All right, let's give it a shot. Fix up. Build. Give me the next batch of errors. Good. So 5 to 8. Yes. I think this piece of code needs some rewrites because it's annoying me. Okay. Maybe we'll use it as a nested function in real. Okay. Put it here. It doesn't have to be private anymore. So oh, wait. I see why it was private. Has a good reason to be private. Okay. So not instead of dropping, we should say replacing prefix with Okay. Let's see if this works. Because essentially it's this logic. Okay. Let me close it up, indent it. So if drive is, if let drive equals drive, drive has prefix, new drive is this, then we can return this path. New prefix. New drive will be new prefix plus drive suffix drive.count minus prefix.com. And then you take the new drive. Take the root. Well, this parenthesis is totally out of place. Root segments. You close it up. Okay. Root equals root. Root has prefix. Prefix. New root will be new prefix plus root suffix, root count, prefix. Okay. And then instead of s path, I'll just return drive is self.drive, root is new root, segments, 3 parentheses, else return self. Okay, that's more like it. Func real. So if you have a UNC prefix, if path as path is path replacing prefix UNC prefix with new UNC prefix. Else, as path is path replacing prefix with nothing. Okay, that's much shorter. All right, let's give this a shot. Conflicts. Okay. More stuff. Okay. 519. Okay, so this is optional, so this must be true. Or this is also optional, so this must be true. This optional value must be true. Anything else? Anything else? Right. 420. Initial value. Initial error is an optional. Okay. Oh, I keep amending. I should do fix ups. Okay, whatever. Script build. Oh, we're getting close. 526. Else if let. Else if let. And then what's this? Name is empty. 377. Oh. I guess in this case is just name is nil. Or I can do this. Okay. And then there's some misspelling here. 392 has prefix. And then I spelled UNC prefix somewhere. Okay. Okay. Let's see if it builds on Windows now. Do a reset again. Load. Boop, boop. Oh, so close. A warning and a missing return. $386. Aha. I need to return path here. And where's the warning? Code path. Yeah, it's used a bunch of places. Okay. So good, so good. Can we get a build? Yes! We got a build. Now, the next part is the tough part, is when we actually run the test. Last time we ran the test, all 3 tests failed. All 3 tests are still failing. Great. Windows main, pathos tests. Let's see what are the details. Pathos tests, real tests. Welcome back, Gilad. Oh! I misspelled something. Pathos tests. Tests. Bonjour. Okay. Unspecified code 2. File exists. Great, great, great. Let me try a few simple solutions because it looks like real tests. I mean, one thing that I did is I didn't make these original files exist. Maybe I can make that happen, like write an empty string. Then I'll make this test exist, right? And then let's fix it up. And we'll build first. Script build. Okay. File exists. Oh man, I hate this because like now I have to debug on Windows, which is really, really rough. All right, I think it's time to face the music. It's time we look at the Windows machine. All right, here we go. Okay, I'm gonna face this direction for a while, I guess. Debugging on Windows is painful. Actually, let me try. We have our do I have our DB? No, maybe not. Okay. All right, print it is. Okay, so first order of business is figure out where the error is thrown. So, well, first order of business, let's try to build our things. I believe this window is already in the shell environment. Yeah, just need to get rid of this. Okay. Okay. Oh, ha. Shoot. Yeah, this 1314 thing means this session doesn't have the privilege to, I guess, inspect symlink or create symlink. So you have to run under the administrator privilege, which means I need to show you guys another window. I mean, okay, this window. Right. Okay. Maybe something like this. Okay, it has the correct environment. Okay, now we're running to the original file exists errors, right? Okay, so let's try to fix it. So first order of business, as I said earlier, figure out where the error is thrown. I'm actually really seriously considering modifying the error so that it includes some kind of context, because right now all I get is the error code. It's really unhelpful when it comes to debugging. I assume for users the experience is going to be similar. Okay, so this is going to be our microscope. We're just going to move arbitrary amount of code in here. Just starting from here. So the error doesn't even begin. It's not even contending here. So it's somewhere in here then. This is tricky. Okay. Oh! Of course, if I catch all the errors, then this test will pass, right? There's no surprise. pathos tests, real tests. Where's our here. Okay. So which of these are throwing this file exists error? I assume it's not this guy, is it? No. Yeah, it's somewhere in here. Let's move one line down. Okay, it's somewhere in here. I mean, it's gotta be this line, right? No, it's not. So the error is from make symlink. Really? So when we're trying to make a symlink, we encounter an error. In a way, that makes me feel better, actually. Because we never actually make the symlink. Okay, let's take a look at make symlink. Make symlink. Oh no. Did I? Man, did I mess the order of these up? How? I thought I have tests for make symlink. Before, I'm just gonna blindly try this out and see what happens. Do I really not have symlink tests? I don't have symlink tests. Okay, I guess that's something we need to do. Let's read the documentation a bit. Create symlink. Okay, create symlink has a symbolic link and target file. Symbolic link is the link to be created. target file is right. So the link file name is the new file name. Target is the target. So the link file in our case is going to be path. So yeah, I confusingly named it target. So this is actually, yeah. Link file. I confused myself by doing that. Okay. All right. So make symlink was broken from the start. But doesn't that, I wonder if that means more tests will be broken. Oh, still only 3 tests are failing. Okay, so does make symlink really lacks some coverage here. But how are these failing? So these are failing. Start test. Wait. Test link as path segment. Resolve 2-level symlink. Simple link. Oh! Resolve simple symlink passed. That's good news. That means, I think. Oh, wait. Passed because perhaps because of this. Okay, simple symlink did pass. But let me comment out this line, right? Because that's the local change we had earlier. Also, I didn't build last time, I think. Okay, so looks like unspecified is related to this. Just to make really sure. Build. Test. Okay, so yeah. In order for the symlink stuff to work, the original path must exist on Windows, looks like, which is not a big deal. Okay. So I need to create this. Everything else should be okay. So I'm hoping this will make more tests pass now. Yep. Now 2-level symlink is passing. We just only need to deal with this last one. The error here is it did return something, but it didn't resolve this symlink. Oh wait, it also threw a unspecified error code 3. Error code 3 is path not found. So I need to create this A thingy. So try. I guess you can see what I'm doing, right? Okay. Try dir plus a write empty string. I'm feeling good about this one. Wait, really? So let's read this again. I mean, this test is passing on POSIX. Hey, Gilad, sorry, as I mentioned earlier in past streams, when I work on Windows, I really suck at reading chat because that's usually where I read the chat. But now it has full screen stuff. So you asked what a symlink is again. Is effectively an alias in the file system. Yeah, it's essentially like a pointer. Yeah, it's implemented differently on Windows and POSIX systems, but yeah, but it's like a special bit in the metadata that marks it as a symlink, and then its actual content is, as far as I understand, is handled differently. Like what is it pointed to? So on Windows, you have to use certain set of Windows APIs, but it's just alias. It could be alias to a file, a directory. The destination can be existent, can be non-existent at all. Yeah, so it can be broken, but the link itself can still exist and stuff. Okay, now I need to. The good thing is when the test failed now, it doesn't show the xct assert equal error now. It's just a system error. Oh, actually, I know what's happening. I think I know what's happening. So this test is actually passing. But this function will attempt to delete that symbolic link, which at this point doesn't when the thing is finished, but it doesn't exist anymore. So I need to manually delete it. Okay, so dir, I guess try dir link dot remove. Is it remove? Delete? Oh, yes. I can't believe it. Oh. Okay. One step closer to finishing this. All right. Pog you. Oh, indentation here is messed up. All right. I guess we will make a new commit. And push it up. And I guess we'll fix the commit real quick. Okay. Let's get it. So squash this up. I guess that's fine. Somewhere in here is a change to symlink, which I think deserves its own commit. But let's just do a git thingy, right? Wait. So I need to split up the last commit into different things. How do I do that? Commit, rebase, I want to do an edit, right? E for edit, yeah. But this commit doesn't, looks like it has any content. What? Daniel, it's delightful to hang out with you while you're working. Thank you. I really enjoy company as well. It is appreciated. Okay, there are some stuff in here. So I guess I just go in and manually revert this change, right? Or I can do a risky move and kind of push all this up as a backup. And then I will reset to the last commit. And then I guess, okay, split this one up and skip this change. Include the rest of the changes. Yes, yes. Very good. Now the only change left is this change. Okay. Now I can commit again and say implement .real for Windows 180 insertions. Now we can include this and say fix symlink, create symlink on Windows. So all of these are valid changes atomically. So now in this pull request, there should be 5 commits. And they each do implement for POSIX, delete some files, and tests, implement for Windows, fix this thing. Okay. So after this is passed and merged, 300 lines of code, we will write some tests for Symlink because that's desperately needed. I can stop all of these now, actually. Cancel if I can. Not that it actually matters. I think I have some sort of quota for how many instances of virtual machines I get to use as an open source project. This guy probably can be canceled as well. Why not? There's no wrong way to use Git, in my opinion. Yeah. I'm just old-fashioned and I learned Git when there aren't a lot of good GUI tools. So, I also helped translate a Git book, ProGit. There's a very popular one. ProGit. Yeah, this book. I volunteered a lot of time translating it. So I learned a lot of unnecessary knowledge for Git, for sure. But it does help. Like a lot of over the years as Git improved its user interface, not the GUI one, but the text one, I have to unlearn a lot of old way of doing things, like deleting a tag or deleting a branch syntax for that, and learn the new syntax. But I still remember a lot of the old ones. To Mandarin, simplified. That's like more than a decade ago. Before I'm like working professionally as a programmer, I was doing everything I can to I guess contribute. Yeah, I didn't know what I was doing. My Mandarin is just as bad as my English, especially when it comes to technical stuff. Like I really lack. I have no idea how to say any of this stuff in Mandarin, because like I was a child when I spoke it. Okay, I guess I just write some tests right now, right? Why the heck not? I'm really surprised that I didn't have test coverage for creating Symlink. Let's use Xcode for a little bit. No, I don't really care for that. Okay. There's no test for Symlink. Dang. Okay. Symlink tests. Really? I feel like I should have some Symlink tests. Let's look at closed pull requests. Right. Where did this go? Symlink tests. It's like this commit. What happened? Did I lose some progress? Yeah, see, I made the fix here as well. What happened to this commit? Monka W. Monka W, dude. What else did I lose? That's why I was so confused, because like I remember that stuff. You know what? Good thing is GitHub have offered the restoration function, so we can kind of symlink. Okay, I'm gonna rebase this, and let's see the delta here. Clear project, implement absolute. Really? That's confusing. Drop this. Clear project. Okay. I think I probably rebased the next branch to include some changes from master, and along the way, for somehow I dropped this pull request. Yeah, this library is used in production in a bunch of places at work, so I had to make some changes for the master branch, the main branch, while this rewrite is still in progress. Okay, so things look good at least. Push this up. Okay, now I can go back here and drop the last commit that I separated out. So in a way, it's totally worth it to have separated it out anyways. This guy, right? Okay. Now I have 2 pull requests open. And I need to open this one. Now I have 2 pull requests open. Wait. Did I not push this up? Oh, right. Wrong branch. Fix a bug where link location and link target were reversed in okay. Okay, so merge this first, rebase that one. Okay, now the good thing is I don't have to write tests anymore because some good guy in the past did it. Yeah. Okay. I think it's good to do this now. Let's see. This function is totally inappropriate for its name. It should be like Can I do this? Hold on. Whatever. First of all, if I rename this and compile, does compiler tell me? It tells me nothing. Okay. Lol. Good thing I have search and replace. So it's calling a couple of places. I want to name it to something else. Also, metadata. Wait, where's metadata implemented? Oh, it's different here. Okay. Oh, right. There's lstat and stat. And in this, we use a special function from Linux kernel. Okay. All right, let's just keep it. I don't want to overcomplicate this. I do want to finish the renaming though. So func real path. This is obviously not real path. It's just final name, something like that. Yeah. Okay. So search for the rest of the real path thingy. Okay. Can I just search replace this whole thing? Okay, yes. Real path. Final name. Okay. Because it's compiling for Mac. Yeah, exactly. Okay, so after this, now it's possible to do this. So this task is children can follow symlink in next. This is actually a backport from master. So when we do children, when we list the content of a directory, some of the content will be symlinks. And when the symlink itself points to a directory, currently we'll just ignore the content for that directory because we found the symlink and we just give it to you. That's problem number one. Problem number two is this function as of right now is not useful. Yes, it does give you a sequence of paths, but what can you do with that path? You don't know whether it's a file, directory, symlink, or anything else, right? So in practice, you always need a type of the path. Well, not always. but a lot of the times you do. Yes. Also, one of the use cases from work made me just now think I need to examine the story of like arbitrary filtration. So what happens is you'll get a list of children, and then you want to do like a dot filter, for example, on it. And in here, right, actually, I have suffix, right? Or extension or something. Oh, okay, good. I think a lot of the filters are done for the like for extensions. So I do have the extension functionality. So maybe it's good enough. Extensions, extension, right. Okay, extension, yeah, okay. Okay, the story there is good enough. Okay, so we just need to include the file type or even the metadata, the entire metadata, if it's convenient. So where do I get this entry? This entry is here. So maybe I just return a file type. Let's look at the Windows implementation. Pass plus Windows, children. So here, what do we have? Find next file. Yeah, we have the data. So we totally could. We already computed the file type. As of right now, we just throw it away, but we should totally include it as part of the return value. Okay, real quick, pee break. Text to speech is really weird. Apparently, it thought P break is the word. I don't even know what that word is. Petrik. That's a word? Anyways. I guess we can make a separate ticket. Okay, let's start merging stuff. This is one commit, squash, merge. This commit now needs to be rebased. Uh-oh. Okay, we'll just let this run. Make a new test though. New issue, I mean. Children does not return file type. Without file type, this function has limited utilities in practice. It's hard and inefficient to find out file types for each children in the sequence. Yeah, yikes, I guess. Okay. Make it a little ticket here, I guess. And we're gonna work on this right now. Not this. It seems generally not bad. Are you referring to the implementation as of right now? I mean, it's not terrible. Wait, do I have a children test even? Yes. Aha, see, this is an area where we can actually... So when I wrote these tests, I don't have the ability to create a directory. I don't have the ability to create a temporary directory. I don't have the ability to create files. Nothing. That's why the tests are like this, right? Because I just picked a directory that's guaranteed to exist and make sure that the result doesn't throw. So now that we have all of that implemented, we can go back and write real tests for this stuff. So that's what I was talking about earlier. That's definitely
something to work on for sure. In fact, let's track that. Okay. Pretty sure there are a lot of other stuff like that. Anyways, let's get on with it. Path plus POSIX. Let's finish this one. So instead of just a test like this, we will modify the target, the return value to include a file type. File type is a protocol, or as we say in the industry, an existential. And we shall return that. I already have file type here, right? So when I add things to the result, it's simply this plus the path type. Okay. Get some cascading failures. What is this? Oh, this is a sample amp. Okay. And just like that, now we're passing. Okay, that's not bad. Let's look at Windows. Same thing. File type. File type must occur somewhere in here, right? Yes. Meta file type. And of course, there's no way to directly verify that things are compiling here. So just eyeball as much as I can. Okay, I think it's okay. This is a easy-ish edit. test is in progress. It's still installing. This test is really slow because it's doing the dance of going to install Ubuntu on Windows and then install Swift and Swift PM on both operating systems, and then cross-compile the project with Swift PM in the Ubuntu inside of Windows, and then run the result of the executable directly in the Windows thingy. So it's really, really slow. I've attempted numerous times to use CMake directly, but I didn't have enough patience to figure out all the syntax and environments, how things interact and all that. It's just a lot of logistical things that I'd rather not spend energy on. Yeah, so so you can choose between PowerShell and command prompt in the virtual machine environment on GitHub Action, and then GitHub Action itself has special syntax for defining environment variables and when things are available, when things are cached or not. Wow, this game syncs the frame rate to a browser open on the other screen, so it's 144 when Chrome is closed and 60 when it's open. Moving you to my iPad as I play. Wonder how the heck they pull that off. Game syncs the frame rate to a browser open on the other screen. So when you're watching me on Chrome, in Chrome, the game's frame rate changes. I guess it's on a PC, so who knows? You probably can detect the Chrome instance, and they probably optimize their game for that or something. So rebase and merge, right? Okay. Okay. Make children return type of children, or each child. It closes 243. Okay. Okay. Let's work on another ticket. Well, actually, I guess I should run tests on the Windows machine here, right? Users, then app data, local temp, org LVM. Okay. Aha! Got something. One 56 0. All right, all tests are passing, so we're good to go. Let's move on. Let's implement this. Can't follow symlink. Yeah. Okay. So we need to add a new parameter to children. Where follow symlink is a thing. And its default value should be the same as what's on master. Children. Follow symlink is false by default. Okay. Now the signature is getting really, really long. Let's format it because we're editing this anyways. Okay, follow symlink. This means let's see. So we need to add an additional thing here. If actually, I'm just gonna read my own code here. Yeah, we start with the checking the path. If path type is symlink, right? And we're following symlink. Follow symlink. And we get the real path. Wait, should we do real path or? I guess. If it's the same link, if we're following same link, and we resolve the same link, and now we have to get the file type for this guy. It must be a directory. Okay, so all this is true. Then we include the result. Recursive follows recursive. Follow symlink is true. Otherwise, if it's recursive, wait, I feel like there's something missing here. This seems broken. Hold on. This is wrong. Oh my god. So if recursive, then we put this inside. Right? If it's recursive, then I'd like to swap this too so that the more common case executes first. Put this here and put this guy after else. Let's see. If it's recursive, then we look at whether the file type is a directory. If it's a directory, then we'll just include its children. But if it's not a directory, we'll take a further look in case we're following the... Oh my god, I don't like this new indentation. If it's the symlink, we're following symlink, and the real path is a directory. Then we use real.children. Okay. Of course, there's no guarantee whether this is working or not. So I have to write more tests, which probably means I'm also working on the other tickets anyways. Okay, just gonna leave this here. Okay, now let's look at Windows. Okay, Funk Children. Follow symlink. Bull false. Okay, it's gonna be pretty similar. If recursive in fact, it's so similar, I probably can just copy the code, right? So we're dealing with meta dot file type, follow link, real is real metadata, file type is directory. If all these are true, we do this. Follow link. Wait, what happens if we follow link but not recursive? Does that require anything? No, let's say it's not. It doesn't do anything when that happens. So now I need to update the documentation. It's just delete the documentation on Windows. Update documentation here, right? Oh. If a child is a symlink to a directory, include it and the directory children. This has no effect when recursive is false. Has no This option has no effect when recursive is false. Okay. Oh no, I rebased instead of squash. Well, I have to fix that. Okay, let's take a look at Windows, make sure things are building. Children follow. Of course, things aren't working, but that's okay. The one time we copied some code over. Okay, so meta.fileType is symlink, and then child.real. We're dealing with is this a path? I guess it's the path. Okay. Looks good. think this is done. Yeah, so that's why we had to implement real at the beginning, because we need to use it here, essentially. Then I guess I'll start writing some tests for children, debug whatever failed test is. Yeah, let's do that next. Children tests. Okay. Okay, so this guy needs to be much more richer. And it closes this guy. 226. Okay, let's write tests. All right, so we need to test the current working directory. That doesn't make much sense, actually. So let's just test some normal directory. Func test children listing children non-recursively throws. Okay. With temporary directory, perform action. Don't care about the actual temporary directory. Now let's make a bunch of files. Path, I don't know, try path A, right, empty string, try path B, make directory, try path B plus C, right, and then we have a bunch of paths now. Oh, try here as well. Now we can do path. Actually, yeah. Let's just use this. Children. Container children. So I don't know what the order of these should be, so I can just assert, I guess, a bunch of things in the children. So let's convert this into an array because it's a sequence before. And then how do I do an array of pairs? Array of tuples. Because I do want to assert the file type as well as how about this? So instead of just turning the sequence to array directly, I can do map, right? And then $0. This would be the path itself. Let's convert it into a string. String describing $0 and then $1 is directory $1 is file is symlink is file. Okay, so now I've basically flattened the information, which reminds me I also want to make a symlink. So try path A, make symlink at path ABCD. Yeah. So now in the directory there should be a symlink from named D, which links to A, which will show up in the children. I guess I can just sort the children. Yeah, I can sort the children. That's not a terrible idea. Sorted. Actually, sort by $0.0. Oh. Okay, sort by name, and then I can assert what to expect. Assert children count. There should be 3. I guess we can do equal here. Because we're anticipating A, B, and D to be in the directory. Assert equal A is the first children's first element. And B is the second children's first element. D is the third children's first element. Okay, let's write some comments. A is a normal file, so we're gonna do XCT assert children I don't know, children 0 is file, right? 1 0 1 2 3, so this one should be true. B is a directory, so directory is the first, well, the second element, and then C, oh, D is a symlink. Actually, this. And symlink is the next one. Okay, so this test should pass on POSIX, please. The only thing that I'm not sure is the sorting. A is not equal to blah 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 blah. A, yep. We have to do name here. Wait, B is a directory, right? Oh, right, children 1 and 2. That's more like it. Yes, easy. Okay, so that's non-recursive. Now if I throw this in, should be recursive. Recursively. Recursive, true. All right. C is a file. So the next children is this. It should be C. And it should have file being true, so 3. D is a symlink. D is the fourth children. And everything else should be okay. Okay. Uh-oh, yeah. There should be 4 children. Okay, recursive works. Now recursive following symlink. Following symlink. Okay. So how do we do this? So basically, we need to make D a symlink of B. And then follow symlink is true. Now, instead of trying this sorting stuff, I think I'll just do something like xt assert children contains where $0 dot segments has was it has suffix suffix 2 equals BD. Wait, it's DC, right? So this should work, first of all, I think. No, it didn't work. Did not work. Okay. I guess instead of doing this, I just children for each print $0.0. Let's first print all the results here. What do we have? We have A, we have D. D is symlink, I hope. And then we have BC and BC again. I don't like this. Instead of BC, it should say DC. Think on that a little bit. Right. Instead of calling real.children, we should be calling. Let's see if I somehow give the original path here. Uh, so instead of self join with the new path, we would do the name joined with path, and this gets added. Hello? Why is this slow? Yeah, it's unclear to me whether it's better to list the real path or the fake path. So let's see what Python does. When in doubt, copy Python. Okay. Actually, probably have something set up already. Okay. So let's make a file A, directory B, link, file C. Okay, and then let's link B to D. Wait. Okay. First of all, why is tree not listing D as a symlink to B? That's concerning. Let's list CDE to A, I guess. Wait. Anyways, we know that D is a symlink to B, right? So let's look at what Python does when it comes to walking. Passlib walk. Does it have walk? Walk. What about os.walk? Okay, it has follow links. Let's try that because it gives us the root, the dirs, and the files, right? Okay. Python 3, import os, os.walk, current directory. It's an object, so we need to read stuff off it. So for root, dirs, files, and this print root dirs files. Should be pretty straightforward. So root is dot, and then we have dirs b, d, and b. Files is a, and then we walk into b. B has no dirs and one file. Interesting. It thinks of D as a directory already. Huh. Now what if I say follow links, right? Follow links. Follow links, print. Now, you walk into B. Aha. So because it doesn't return the absolute path, but it does return B. Okay, I see. So there's a couple of interesting things here. When D is a symlink to B, a folder, Python considers the symlink a folder as well. And then when it walks into recursively into the whole thing, it does walk into D, the symlink, with the duplicated content from between B and D. So the second one is easier to copy. The first one, I need to think about this. So it implies that a file, at least in terms of walking, whether a file is a directory is determined not just by the fact that it's not symlink. In other words, symlink and directory are not mutually exclusive. So that's pretty interesting. Yeah, I definitely want to emulate that. Okay, so let's update our test to reflect that. Children tests. Okay, so what should we expect here? We have an A, B, B/C, and D, which links to B, right? So in our result, what's the right thing to do? because like so when a symlink to a directory is considered here. Okay. Pee break. Okay. One thing that I didn't expect is that things got turned into absolute paths. Let's see. Children is absolute getting called somewhere. Shouldn't be, right? Print self and name. Let's print this out and see what happens. Ah, I see. So it's the problem is this. I should do like path dot children. That's much better, right? Yeah. Take advantage of the current working directory and get rid of the noise for the tests. Okay. Except when we call real path. When we call real path, it turns things into the absolute path, which is not correct. Okay, so maybe real path is too hardcore. Read symlink. So now we've got A, D, B, C, B, B, C. Okay. Why isn't right? So here I need to do real. Let's call it link. And then this will be link target. And link will be joined with link. Right? I think this is much, much better. If it compiles at all. Target. Oh, case. Okay. Okay, so we have A, D, B, C, B, B, C. Okay, now the actual result should be A, D, B, C, A, D, D, C, B, B, C. Okay. So how do we do that? Well, let's write the test first. I guess I'll just map the names. Turn it into a set. Okay, and then I can just say XCT assert names equal that list. Except this should be D and it should go like this. Can sort this if I want to, but Really? Okay. Sorted. Path needs to conform to comparable. $0 dot binary. Binary path. Okay. What if I just make the paths comparable? It doesn't make sense to be comparable, does it? I guess people may want to sort their paths. So extension path comparable. Okay. So what does it mean for one path to be less than the other path? Path has binary path, sorry. Binary path is binary string. Binary string is either Windows or an expanded string. Oops. Which is just a C string, right? Okay. So I need to make this guy comparable. Really? Can I do like zip? All satisfy. Maybe something like this. Okay. I don't get it. Is path not equatable? Yes, it is. What is it complaining about here? Oh, yes, yes, yes. So these guys all need to be paths. Okay. I mean, it's not gonna be correct, but at least I need to sort these guys first. A, B, A, D, B, C, B, C. A, D, D, C, B, B, C. Is this really sorted? A, D, B. Doesn't look sorted to me. So my sort is wrong. So I'm zipping left and right, right? And then we take the storage. We're saying if A equals B, if left is less than right, then each element of left must be less than right. No, that doesn't seem right. So it should be like for L are in this. If L so really it's like the zip contains, right? Contains $0 smaller than $1. If it has any of this, then yeah. Okay, so now let's run this again. Now we have A, B, B, C, B, C, D. Okay. And in reality, we're anticipating A, B, B, C, D, D, C. Okay, we need to make this test pass. And I have reason to believe the test is correct. Okay. All right, so let me think. So I probably need to wrap everything inside in a different function. Let's call it children implementation. And it has almost the same signature, except it'll take an additional parameter. Okay, so I guess it's called logical parent, or texture. Yeah, logical parent. Recursive follow. Okay. And then we'll call this starting with nil, I guess. So if we find a symlink, we shouldn't call this anymore. Should call children info logical parent nil. Oh, right. So this thing can't be... It can't be nested. That's not a big deal. Just move it so that it is outside, yet internal. Okay. And it's going to be self-recursive. Just stay down here. Children implementation. Okay. And it shall not call anything except itself. Implementation. In this branch, I think you don't need a logical parent. And in this branch, it does need a logical parent. Man, children implementation is so long. Let's just call it children impo. Oh my god. Okay. Impl. Logical parent. So this is the interesting case. We'll leave it like that. So we can pass in the logical parent. The logical parent in this case is self joined with link target, right? And when you append result, you should first see if logical parent exists. Logical parent or self plus name. This is the result. Okay. Joined with okay, so now we got A, B, B, C, B, C, D. That's not right at all. A, B, B, C, B, C, D. Okay. So we didn't get the D. Okay, let's try this. Let's print out the logical parent or the actual parent used. I mean, I know it's not going to be correct. Or maybe I just put some breakpoint if it works at all. Yeah. Okay. Does anything work here? Snail self is something. Oh, okay. So it's working. Or not. Totally useless. Okay. Oh, right. It shouldn't be linked target. It should be pop self or child. Child. Should be child. Okay. I think this is better. Oh no. Not child. Just name. Oh. So it passes, but I think it's not good enough. Let me print this again. See what happens. Okay, so why does it feel wrong? Because it seems to me that okay, let's try to fill it again. What if I add a so B and D? What if I make a B C? Wait, B C D E. Okay, so this won't. First of all, it will fail, but I want to look at the output here. So we got BE, okay. And then we will add F. And then F is going to be a file. All right. Does it give me the right result? A, B, B, C, B, E, B, F, yep, D, D, C, D, E, D, F. It is correct. Okay, I like that. Just need to update this list, right? We have A, we have B, we have BC, BE, BF, D, basically the same thing except D, and D itself. Okay. Nice. Now make this work on Windows. Okay. Uh-oh. Oh. One failure. Zero failure. Oh no, there's a failure on Linux but not on Mac OS. That's not good. So on Linux we got A, B, D, D. A, B, D. That makes sense. Why isn't D included on macOS? Oh, wait, what? A, B, D, B, C, D, C. It's just order difference, right? Is it a Indianness problem? Maybe I can convert this into sets instead. That's much simpler, much cleaner. Yeah. Yeah, it's an Indianness problem, isn't it? Okay, there goes, there passed the test. This turns out to be a little more complex than I anticipated, which is not a problem at all. So actually, this is partially follow-up for the previous. Oh, let's just follow it up. Let's just add it to the previous pull request. And we know on Windows it will fail, but we will fix it on Windows. Okay, so what did we change? Here, let's take a look here. We added the concept of a logical parent. So we need to do that on Windows. POSIX plus, sorry, pass plus Windows. So instead of real, we should run read link, read symlink. And then we have to essentially do this, duplicate this, make an internal version of this, add a logical parent thingy, and start off without a logical parent. Wait, what if the path is itself a symlink? Not sure. Need to add a test for that as well. Okay, so this is going to be children impl, and this guy just calls children impl. Children impl. Now logical parent is now recursive follow symlink, and this will call impl logical parent now. Impl okay, so this is not, shouldn't be now. It should be, my brain power is depleting, so I'm just gonna reference this instead. So once you find out the name, you should join it with parent. So this should be joined with what? The binary, right? Okay. And the path, let's see. Path. So when we add the result, it should be I guess we'll do a logical path. Logical parent, self, joined is binary, right? And then here you can use the logical path. And here you use logical paths. This seems like a good saving that I can use on the other file as well. POSIX. Right, this is wrong. This should be just this. Then logical child is what it was before. Logical child appears here. Okay. Does this still pass my test? Should be. It does not. Why doesn't it? So we got BD. Wait. What? Okay, let's see what is actually missing. Okay. So we got A, B, Okay, wait, one by one. D is here. BE. Actually, let's go with reverse. A is in here. BE is in here. D is in here. DC is here. BF is in here. Oh, looks like DE and DF is missing. Okay, why? Okay, I'm gonna not change this and debug over Windows because it's not worth it. Okay, I think what happens is not sure. Okay. Okay, syntax error. I mean, it's probably gonna fail with the same similar error, right? 2 failures instead of 1. Build Windows bin Windows main pathos tests. Okay. One of this is because I didn't create some files. Let's look at this one. We have B, we have D, F, B, C, B, E, A, B, F, D. Wait. Right. Hold on. First of all, the test needs some updating because it's hard-coded stuff. This should be plus A plus B BC, BE, BEF, D, DC, DE, DF. Okay. Path. Oh. Okay. Update this test. Okay, the next thing is, for some reason, the root parent directory is not included in Windows. Add result if necessary. Okay. So for some reason our Windows dot slash got deleted. I have a feeling it's not local. It's not in here. Have a feeling. Logical path. So obviously it is included in the result. So maybe it's when we join binary, joined with, so binary string join. Join with Windows convertible. Okay. Okay. Yes, I think this is the culprit. Here we're dealing with, we make everything into a Windows path. That part is okay. self. Okay. Yeah, we'll create a pure Windows path. Pure Windows path. Actually, I'm slightly confused because according to this, right? We're getting all the segments. What if I print out all the segments here? Okay. Build. Okay, test. So here are the segments, right? The segments never included the current working directory, which is very interesting. So we start off with self being the current being the dot. Okay, so here okay, we use this star pattern to find the first file. All right. I'm gonna define this in a better place instead of just declare it right honking here. How about we define it at the beginning? Okay, so now and result if necessary. It gets a data. Data has the file name, but doesn't have. I see. And result is necessary. It takes the data, and data is everything. Is all that it uses. Except this, right? This does use self. build and test. Yeah, so it is a problem with joined with. Yeah. Okay. All right. Let's see. Oh, Really? Path parse tests. Path parts tests. Ah, here. So this is for Windows. Let's just write a test here. Test initial context is preserved, right? Let p equals pure Windows path dot a, or just dot, equals p dot segments dot. I mean, this test must be failing, right? Yeah. Initial context with follow up reserved. So if it's a backslash dot backslash a, we should get a. Okay, so this should fail. This should fail as well. Okay. Okay, so it has something to do with the initialization. When you create a thing, when you pass a string to Windows binary string, hello. Okay, so it's a C string. C string takes initializer. Where is it? Must be in parts. Right. Okay. All right. Good thing is we have a test now that runs here. I think this test should also run for parts parsing. Okay. Okay, both of these, all four of these should be failing, and let's make it pass. Okay. Okay. Let's see. So this is called by this guy, which is called by this guy, which is called by. Okay. Oh, it got removed here. Right? Is empty is false. Oh, wait, hold on. Here. Let's take a look at rest. Okay. So it's not here. Not here. Go again. Boop, 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 boop. Forty-six. Okay, so you split 46 by the separator. Okay, so this normalization is too simplistic. We need to make it slightly more sophisticated. So you split everything by separator. Now you need to enumerate. Enumerate. And now you say dot enumerate give you the index, right? Okay. So here is where you say instead of $0, $1, you say $1, which should be just fine. Okay. And tests are failing. Now you can say or $0 greater than 0 and. Okay. No? Let's see. $1 count is 1. Okay. Let's see some of these failures. Windows parsing. Parts parsing. Are these still failing? Okay. Wait. So I guess it's like this. You filter by if count is greater than 0, then it's fine. Right? Otherwise, you need to do not this. Okay. If it's not the initial segment and it is the current context character, then you filter it out. How about now? Yes. So simplifying that would be $0 is 0, or this is not that. Yes. Is that clearer than this? I feel like this is clearer. Okay. Interesting. Pull it, build it, run it. Now we have one failure. Yes, the failure now is just the fact that something doesn't exist, which is great because I think I know how to fix that. So children tests. Let's see. We made A, we made B, we made... Oh yeah, this is just a quirk where we need to delete the symlinks. Wait, this is actually something that we should let's see, delete. Okay, so when we delete a file, if the error is the fact is the error is the file doesn't exist, we should be happy. Okay. So let's add a bunch of stuff in here. Whenever we throw, let's print the line number. Yeah, the error handling story needs to be better. Yeah. Okay. All right, let's see. Wait, it's not in delete? It has to be in delete. Throw, 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 throw. With temporary directory, perform action. Okay. I assume it's this guy throwing error. Do catch print delete error. Whoa, it's not delete error. Huh. That's new. Okay, then what is it then? It is definitely test listing recursive following symbolic link. And it threw an error 3. Okay. Let's find this. So somewhere in here we've got an error. Let's use the bracket method. Do catch error. Bracket everything in here. We know this definitely throws the error, but this will make the test pass, right? What if we take like half of these out? All right. Okay, tests are still passing over here. And on Windows, let's build. Run that test. Okay, the error got thrown, so it didn't get caught. That means we bracketed too late. Interesting. So it's somewhere earlier. let's see. B make directory. BE make directory. BF write. Make directory with parents false. Oh! Should I? Is it with parents true? Let me think. Maybe. Well, let me finish the bracketing first, I guess. Okay. It's almost guaranteed it's, I mean, it is guaranteed it's that block of code somewhere in there. But but what if it's not, right? Let's see. Test listing children recursively following symlink. That's this test. Yep. Now, if I say children tests, okay, this is going well. Okay, this is somewhat readable, right? All right, so the bracketing is in here. Sorry about that. That's really bad, terrible. But if I build, things appears to have been built. Run tests. So this gets thrown. We know that the problem is not there. All right, let's keep trying then. Doesn't that mean the problem is actually outside? We know we bracketed, we tried to catch it here. It didn't get caught. We tried to catch here, it didn't get caught. So the only logical place is outside everything, right? Has to be here. I mean, I'll be really surprised if this doesn't make the test pass because we swallows the error. Yep. So that tells me it is with temporary directory that's throwing the error, right? Temporary directory. It's this guy that's throwing the error, no? Let's get rid of this. Print debugging. So fun. All right. Do catch. Actually, this is a much better place to bracket. Let's, for example, you can just say, hey, you know, whatever this action is, bracket that, right? And then you say, print out the error if you catch one, but don't throw it further. Yeah. Okay. Oh, we're almost there. Almost there.
I think this will verify that the error is indeed in with temporary directory as opposed to our code. Yes, because the test failed. That means we didn't catch the error. So it's not this line. So it's either this line or this line or this line, right? But also I tried this line, I think. But just for my own sanity, I guess I'll try it again. Because this was what I anticipated to be where the problem is, and it didn't show up. Didn't turn out that way, which is what confused me. I should have more conviction, I guess, in terms of my intuition. All right. Ladies and gentlemen, if you're confused, on the right screen, right side of the screen is a SSH session into Windows. Hey, Rockstar. Yeah, this is I'm because I'm working on library, so it is a little bit more than the I guess what you would see normally. Wait, did I? Let's see. What happened here? Did I pushed over there, right? Did I pull? Build. Run tests. Wait, we did catch it. Okay. So I know what to do. I know what to do. So the reason is, let's think. So something is wrong in delete. Func delete. That's in path plus Windows. Func delete. All right. So something is wrong in here. But I put in all these print statements and none of it triggered. What? All right. Do it's a big Beethoven energy over there. Let's try this. Okay. So because Swift is so, it's not very well supported on Windows, so I have to resolve to this kind of commit on this machine, adding some print statements, pull that changes down on the other machine, build it, run it, and see what prints. Hopefully things will change. Build. Yeah, dun. Of course. Wait. It triggered on 179. Did it trigger the whole time? I just was blind and didn't see it. 179. 179. Okay, we're removing a directory. And it failed, complaining that Windows error codes. Number 3. The system cannot find the path specified. Right. And let's take a guess at what path that is.
I mean, the right question is like if you're trying to delete a directory and the directory turns out to not exist, isn't that kind of good? Like, why complain? Seems good to me. Path not found. Seems good to me. Maybe we can just swallow that special case here. Yeah, that makes sense. Path not found. Okay, let's eat it. Okay, if error code is path, what is it? Error path not found. Well, how about if it is an error path not found? Let's throw, otherwise we're done, right? We're trying to delete the file, blah, 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 blah. Okay. Okay, this, good. Move, whatever, remove directory. Okay. I like this. I like where this is headed. Yeah, because what's happening is we created a symbolic link to a directory, and when we clean up the temporary directory, we deleted probably one of these, either the original directory or the symbolic link to it. And now we're trying to delete it again because there's a link and there's an original one, and one of them errors, which I don't think it should. Yeah. I'm gonna I guess I keep this for now, right? Okay. All right. Build. Wait, did I put on new content? No. Oh, because I didn't push. Okay. Type error, D word, and int32. Great. Which side is the D word? Oh, get lost error, first of all. Okay. Get lost error gives a D word. Okay. Okay. I'm thinking, yeah, whatever. I don't want to do too much. dramatic change here. Or just make this a D word. Actually, I think my choice to represent the error code here is wrong. It should be a D word. Wait. No. I think the brackets is the only thing I need. I don't need to further convert this. Okay. Oh. Build. Run the tests. And all the tests passed, but we did a couple of these. What does that mean? Comment out. Go away. Wait, that means this guy threw an error. More than one error. Huh. Okay, so unspecified error number 3 and error number 145. What is 145? Directory is not empty. That's because that's a side effect of this not finishing. But number 3, error success, blah, blah, blah. Number 3. Who's throwing number 3 here? Number 3. Okay. It's gonna be one of these move ones. All right, let's write a small utility function here. Func error throws, right? And it's gonna do something like this. So the theory goes, we're either trying to move a file or delete a file. So in either case, the file doesn't exist is fine. Okay, now I can I think I can delete this now. At least we won't get error number 3 anymore from this function. No! What did I just say? What? I'm trolling. Where is it from? Is it from here? Bruh. What in the heck? Okay, seeing here. Throwing error code. Error code. Okay. Okay. So it's not thrown from here. That's good news. Okay. That's good news. That's good news. Okay. We are getting close, I feel like. Temporary name. Oh, is it this guy? No. It's not that guy. So it has to be one of these. Yeah? Oh, it's not one of these. It's this? It's in children. Oh my god. Are you serious? Yeah, it's children. That actually makes more sense. Ah, okay. Children tests. So D is a sim link. And at some point we're going into these children. Okay. Okay. I shouldn't be surprised. Okay. Children. Okay. This seems to be wrong. Is path. Oh, wait. Wait. I think this needs to go, first of all, this needs to go in here. That's just a normal logical error. Okay. Let's see if that helps. Okay, I think I earned a break after this, if this works. Okay, blah, blah, blah. This is still wrong, still wrong. Okay. I don't get it. I don't get it. Metadata plus Windows. Okay. So, so this could be both true, I guess. That could be a reason why this is messed up. Yeah, both are true. Oh boy. Oh boy. Oh boy. Oh boy. Okay, so I really need to fix this then. Is directory equals this? It's symlink equals this. If is directory and is not symlink, it's directory. Otherwise, if it's a symlink, yeah. I wonder what this breaks. I know that fixes our test at hand, but it must break something else. I remember fondling the order of those flags in the past to fix something. Let's run all tests. We have 2 failures. And if I run my only test, there's 1 failure. So something else is failing. Okay. A, B, F, B, F, D, E, D, D, E. Wait. What's error number 5? Access denied.
This is really strange. Where is the leading dot from here? I don't understand. Access denied. Okay, so what is the other test that's failing? I'm just looking at this computer. This children is recursively failed. Link path segment failed. So the problem is on Windows, a thing can be a symlink and a directory. Which is different. On Linux and Mac OS, symlink is not a directory nor a file. So maybe this thing, instead of being a struct, should be instead of being an enum, should be a struct. And instead of doing this, we should do this.
And then here we should do is directory this is file is symlink is this is file is not directory, and then file type equals is file is directory symlink. Is file is directory is symlink. And then we can get rid of this. Wonder what this does. That is closer to reality, but also requires more documentation, proper update to documentation. Because it's kind of not what I've been trying to design. Windows file type. Oh. Okay, so we still got the same error, but I guess now we have more information to fix it. So when it's directory and symlink, we handle it as a symlink. But, wouldn't I just bring this forward? Whatever. Here we need to say case logical. Wait. I think that's it. Ooh, please be it. Okay, we're not throwing the error anymore, right? Now it's just a matter of the eventual value. For some reason, we have BFBFD. Huh. Okay, we're not trying to visit a non-existent value anymore. That's good. Now the question is, why is it join with? No. This should be logical parent should be joined with logical path, right?
Okay. So why am I trying to visit D, which doesn't exist, right? Pass. Logical. Wait, that's obvious because path at some point is D. Path at some point is D. Its type is directory and it's not a symlink. Therefore, it's accessed here and it throws an error, right? First of all, why isn't this different? We have A, we have B, D, D, D. We have BE. We have A. We have DEF. Oh, DEF is BF. Interesting. Okay, I need to think about this instead of trying to poke at it. It's right here. Okay. Oh, come on. Hmm. 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 So somehow, when we clean everything up, this folder gets passed in, which doesn't exist. And we're trying to read it as a string, as a directory. But what I'm trying to figure out is who's passing that in, right? Let's see. Delete. Let's look at delete real quick. Right, of course, it's being passed in here. Yes, I think this will fix it. This will fix the error being thrown. Except that one. Except that one. Access is denied. Okay, so we know that the children part is fixed. All right, so access is denied is an error thrown by deletion. Okay. And this is also failing, so we need to fix that as well. But throwing 5. And it's not being thrown from here. Wait, is this one of those? Okay, it doesn't matter whether you run it with an administrator privilege or not. I see. If it's recursive and method is not symlink, then we visit its children and delete its children. Otherwise, we just delete it as a directory.
Ah, no, 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 no. Will this work? Oh, it worked. Okay. So the only thing left is to figure out why this is not working. So we're looking for BC. BC is here. We're looking for DE. DE is here. We're looking for BE. BE is here. DC. DC is here. B. D. BF. BF. DF. Looks like DF is missing. Okay. All right, so delete is working. Children is still broken. Func children. Okay. All right, let's look at these, right? So at some point we should have the path being B and logical path being D. Path B, logical path D. A, B, 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 path D, logical D. That's wrong. Oh, that worked.
Okay, everything's working now. Wow, that was pretty tough. Pretty tough. I think it as the day goes on, my concentration just couldn't pull together, because all I needed at the end is a little bit of I guess logical deduction, and at some point all I have left is banging things against the wall. Okay, so let's delete all the print statements. And rebase against this. There'll be a lot of fix-ups. I guess we'll just clap everything. And let's just read this patch real quick. So, added sorting, we moved this to its implementation so that we can pass in the logical parent. We changed the way file type works on Windows, because you can now be both a directory and a symlink. This is a moved function with the modification of the logical parent. For deletion, we exempt the error path not found. And then we only attempt to visit the children if the directory is not a symlink. And the tests. Let's run the test on Linux real quick. Okay, so where are we even? What are we even doing here? So follow symlink is done. Lax text coverage is kind of done as well. Every test passed on Linux. Great. Okay. This one is going to be forced push. Okay. After this, I'll merge this, I'll close the tickets, and I think that's it for this stream. I don't think I will actually stop. I just feel a little exhausted from streaming, so I need to take a break. But thank you so much for watching. If you watched all the way here, I really appreciate it. If you're watching on YouTube, consider watching me on Twitch. And yep. But also give me a subscribe if you are watching on YouTube, in case you want more streams like this in the future. Anyways, thanks for watching.